Okay, the difference quotient. So the expression f of x plus h minus f of x over h is the difference quotient, and it plays a vital role in the study of calculus. So if you end up in a calculus class, you will see this again. If you never end up in a calculus class, you will never see it again. And you're just learning how to do it so you can get the problem on the test right, or problems on the test right. All we're going to do with it is find and simplify it. You do not have to memorize that expression. I will always tell you, find the difference quotient, then I will give you the difference quotient, so you don't have to memorize it. Steps to finding and simplifying the difference quotient. 1, find f of x plus h. To do this, replace all the x's in f's rule with x plus h. 2, find negative f of x. Do this by subtracting f's rule in parentheses. 3, fully simplify the numerator. This may mean foiling, distributing, and combining like terms. When the numerator is fully simplified, there should be an h in each term. If a term is missing an h, a mistake has been made. 4, cancel h from all terms. Always those steps. Okay, so let's do this first. I don't know why it occasionally blanks out like that, but it just occasionally blanks out like that. But anyway, find and simplify the difference quotient. F of x equals 2x minus 5. So f of x plus h minus f of x all over h. And I just like to do it in one big thing, but we will label the steps as we go along. F of x plus h. That means use my formula, but replace the x with x plus h. So there's step 1, f of x plus h. Take my formula, replace the x with x plus h. Step 2, minus f of x. So minus parentheses and then the formula. So there's step 2, minus f of x. With those parentheses being absolutely vital, the most common mistake of people knowing essentially what they're doing is they're forgetting those parentheses. All over h. Step 3, simplify. So we're going to get 2x plus 2h minus 5 minus 2x plus 5, which gives me 2h over h. When you have completely simplified the numerator, everyone should have an h. If someone is missing an h, you've made a mistake, stop, go back and find your mistake. But at this point, everybody should have an h. When the numerator is fully simplified, there should be an h in each term. If a term is missing an h, a mistake has been made. And then step 4, cancel the h. And this guy equals 2. And we have found and simplified the difference quotient. Always those steps. The only difference is going to be is how much work you have to do in this simplification step. Let's do it again. A little more complicated formula this time. Okay. F of x plus h minus f of x all over h. So that's going to be 4 times x plus h quantity squared minus 3 times x plus h plus 5. There is step 1, f of x plus h. I take my formula for f, I replace every x with x plus h using very careful parentheses. When it says x squared, that means square all of the replacement. So square all of the quantity 8x plus h, so it has to be in parentheses. Then minus f of x, and that's just minus the formula. And so there's step 2, minus f of x. Then the rest of it is just all over h. And then 3, we start to simplify. And this is just going to take some more work in simplifying than the previous one. So I'm going to eventually FOIL that x plus h quantity squared out. So I'm going to write it as x plus h, x plus h. Distribute that minus 3, so minus 3x minus 3h plus 5. Then minus 4x squared plus 3x minus 5 all over h. Keep simplifying. So notice we got some stuff that's already going to go away. The negative 3x plus 3x, 5 minus 5. Do my foiling here, and so that's going to be x squared plus xh plus xh plus h squared minus 3h minus 4x squared all over h. And I am trying to show every step I can simplify, every step I can show. Got some like terms in there, so xh plus xh is 2xh. Still all over h. Distribute that 4, and so I've got 4x squared plus 8xh plus 4h squared minus 3h minus 4x squared all over h. The 4x squareds can cancel. And so we're down to 8xh plus 4h squared minus 3h all over h. And note, all terms have an h. And that's what you want. You want everybody to have an h. So step 4, cancel the h's. And this step is only legal if everybody has an h. And so this is going to become, very technically, 8x plus 4h, because you're just canceling out one of them. So there, canceling out one of them, canceling that, minus 3, very technically over 1. Remember, canceling is really division. H divided by h is 1, but no one ever writes denominators of 1. And so the answer here would be 8x plus 4h minus 3. And there's my difference quotient. And so it's the same steps every time. You just have to be really careful with the simplification in the middle. Okay, on to the last topic in this section. Piecewise defined functions. The following is a piecewise defined function. F of x equal 2x minus 3 if x is less than -1, x squared minus 4 if x is greater than or equal to -1. The function has two branches. The inequalities that follow the word if are called the restrictions and indicate when to use each branch. I've seen some videos that call those the inequalities that follow the if domains. I prefer the word restrictions, but they tell you when to use each branch. For example, if you were asked to find f of -5, we note that x equals -5, that x values go into the function, and since x values go into the function, and thus our x value is less than -1, so we use the rule 2x minus 3. And we will talk about that in much greater detail in a minute. Piecewise defined functions actually occur in real life all the time. The drinking laws in this country are a piecewise defined function. If your age is less than 21, it's illegal for you to drink alcohol. Greater than or equal to 21, legal to drink alcohol. That's a piecewise defined function where the action you take depends on your relationship between to 21. The tax laws are piecewise defined functions. If you make so much money, pay this tax. Another amount of money, pay a different tax. So there are many real-life examples of piecewise defined functions. All we're going to do with piecewise defined functions is evaluate them. Now, I'm going to beat this to death, but come test time, all I hope you do is write down the answer. So here, beating this to death. There is my x value. X's go in. X is 8. I go now and compare it to my restrictions. If x equals 8, then x greater than or equal to -1 is true. And so I will use x squared minus 4. And so then that tells me that f of 8 is 8 squared minus 4, 64 minus 4, 60. Done. All I would be hoping to see on a test is that right there. Everything else is your thought process. And it's only equal to one answer. Remember, it's a function. One number comes in, one number comes out. And then you don't really care what this number is here. I will let students then take this 60 and then do something with the restrictions. No, you don't want to do that, because this is technically a y value. And so since this is a y value, you don't compare it to these restrictions. Just get the answer and stop. Same thing on the next one. There's my x value. X equals -1. X's go in. So I look at what my x value is, then I look at my restrictions, then x greater than or -1 is true. So I use, again, x squared minus 4. And so f of -1 is going to be -1 squared minus 4. Notice the careful use of parentheses, which is going to be 1 minus 4, or -3. And one more time. There's my x value. X equal -10. Then I go and look at my restrictions. And if x is -10, then x less than -1 is true. And so I use 2x minus 3. And so f of -10 is 2 times -10 minus 3 for -23. And then stop. We don't do anything else. You don't compare these y values to that x guy up there. 2 more times and we'll be done. Got a new function there, so there's my new function. We can see it. Find f of 4. Same deal. X equals 4, so x is not -2. That's what's true. X is 4. It is not -2. So use x cubed plus 1 over x plus 2. And so f of 4 is 4 cubed plus 1 over 4 plus 2 for 64 plus 1 over 6 for 65, 6. Here, last one, x equals -2. So x equals -2. There's my two restrictions. My restrictions are only equal and not equal to a certain number. So on this first one, x was 4, so x is not equal to -2. I see you use the top one. But here, x equals -2. And so what this guy is saying is when x equals -2, the answer is always 5. That there isn't a formula to plug in here, that whenever x is -2, the answer is always 5. So f of -2 is 5. And that's the end of this section and the end of this video.